Okay, in 12.2 day 1, we're going to explore what are called arithmetic sequences. We actually talked about them a little bit, just did not identify them as the arithmetic, because arithmetic sequences are linear. So we are going to identify and find terms and the common difference of an arithmetic sequence. Okay, and then the definition is just for a sequence where the terms are differing by the same number, which they call D, because it is the common difference. Okay, and because of this, the common difference, all the first differences are constant, so we know that it is going to be linear. Okay, so for the equation, if you need to find the nth term, you can use this equation, a sub n equals a sub 1 plus n minus 1 times d. Okay, so this is the nth term, a sub n, and here a sub 1 is the first term, d is what we call the common difference. Sometimes you will see this written without the a sub 1 term, so it is also known as a sub n equals a plus n minus 1 times d. Alright, so for example 1, a sequence is given. Part A, you're going to find the first 5 terms of the sequence. You know how to do this, so I'm going to let you cook. Find these 5. And then if you want to try part B, you can. When you're finding the common difference, okay, so to find those terms, you're just plugging in the value 1. Tell me what you get for a sub 1. 2, great. Joel, what you get for a sub 2? 1. 1, nice. And then Lucas, what you get for a sub 3? 0. Elliot, what you get for a sub 4? Good. And then Alora, what you get for a sub 5? -2. So then when you're going to part B, what is the common difference? Okay, all you have to do is see what this constant difference is. So to go from 2 to 1, what are we doing to 2? Subtracting 1. Okay, here subtract 1, subtract 1, subtract 1. Okay, a lot of times the common difference you can find just by looking at it, but in case you have a more complicated sequence, you can always use this equation. It's always a sub 2 minus a sub 1. So when we have fractions, that's going to be beneficial. Okay, so 1 minus 2 is -1. Okay, and then in part C, we are going to have to extend this. In part C, we are graphing the terms that we found in part A. So a point is just the input and the output. So for this, we plugged in 1, our output was 2. So we're going to graph 1, 2, 2, 1, 3, 0, 4, -1, 5, -2. Now, do we connect these or not, and why? Do we connect these or not, and why do we or why don't? What do we think? connect the points or not in the sequence? No, because what's the domain of a sequence? The counting numbers, okay? So you're not going to connect them. Do not connect the points. Okay, so when you're plotting your points, like we said, we're just going to extend this here. So we have 1, 2, 2, 1, 3, 0, 1, negative 1, 5, negative 2. Okay, and then when you're graphing, there are just a few of them you have to graph. You don't have to put that on graph paper. You can just use the line paper as the grid. That's fine. Okay, because you're not going to be connected those. All right, and then example 2, we have to determine whether it's arithmetic. And if it is, then we find the common difference. Okay, so all we have to do is see if the first differences are the same. A lot of times you're going to be able to tell right away. So to get from negative 10 to 4, we'll just add 6. Same thing from negative 4 to 2, 2 to 8. So if the first differences are constant, okay, then it is arithmetic, it is linear. Okay, and then in terms of showing work when you are doing this on your own, okay, you don't have to write this in. A lot of you are going to notice that right away. It is fine if you just say yes and then d is equal to 6. Okay, I do want you to have this for your notes, so when you go back and you look, you remember the y. The first differences are constant, and that's why it's going to be arithmetic. Okay, as we go to part B, we're going to do the same thing. So from 2 to negative 5, we subtract 3. Here we subtract negative 6. As soon as you know the first differences are not constant, you can just say no. Okay, again, when you're doing that on your own, it's fine if you just say no. Okay, and we can see that those first differences are not constant there. All right, for this one, there's several things we have to find. The common difference, the fifth term, the nth term, and the 100th term. Remember, whenever you're given a sequence, what they're giving you are those term numbers. So 11 is a sub 1. 8 is a sub 2. Okay, so on and so forth. So if you're going to find the common difference, you can just do a sub 2 minus a sub 1. Okay, so the common difference, that value of d is negative 3. That's also easy to see from your sequence. Now we're going to find the fifth term. Well, if you already have the fourth term, okay, the fifth term is just a sub 4 plus the value of d. So it's 2 minus 3. That's your a sub 5. Okay, again, that's something you can do using mental math. That is fine. You can just write a sub 5 equals negative 1. This is where it's coming from. And then we're going to find the nth term. So earlier today, we highlighted what the equation was for a sequence. Okay, you can find that above. It's a sub n is equal to a sub 1 plus n minus 1 times d. So whenever you are finding the nth term, remember that means you're finding an equation. Okay, so now what we can do is we can plug in different values and we can find our equation. So our a sub 1 is 11. The equation is always going to have n in it, so you won't replace that with anything. Okay, and then the common difference is negative 3. Okay, we have done this earlier. So earlier we just said, hey, it's linear, and we kind of guessed and checked. You can still do it that way, or you can just use this formula and simplify. So when you simplify, you're going to distribute. Even though it's in the back, you can distribute it to both of these. So 11 minus 3n plus 3. Okay, so you can see it's still in the form y equals mx plus b, except instead of x, we're using the variable n. Okay, and then remember how we said the common difference is the slope? We can see that's still true, right? -3 is equal to the common difference. Now, if you're checking this, checking your answers in the back of the book, just so you know, sometimes they write it in an unsimplified version. So if you see something like this, a sub n equals 11 minus 3 times n minus 1, that is this, but unsimplified. Okay, you just distribute the -3 and then clean it up. All right, and then do we remember how to find the 100 term? We want to find a sub 100, what do we do? Yeah, we're just going to plug in 100 for n. This is something we can do in mental math. And you have your assessment. Some of them will be your calculator. Okay, so if you're adding on to a negative, just add 10 first. -290, -290, plus that 4. Alright, so now I want you to go ahead and do part B. You are going to be working with fractions, which means you may have to get the common denominator, but go ahead and do the first few steps. Okay, so step 1, find the common difference. So 5 thirds minus 7 6. Okay, so just double check, make sure you got d equals 1/2. When I came around, most of you already have that. And then for the a sub 5, you can always take this last term and then apply the value of d. Okay, so you can get a common denominator, so times 2 times 2 times 3 times 3 Okay, so you have 19 over 6 for a sub 5. Now when you go to a sub n, you're going to plug in that a sub 1 is 7/6 from your given sequence. Okay, and then n minus 1 times the value of g, which is 1/2. So 7/6 plus 1/2, n minus 1/2. And for this one, I like to okay, so I have 1/2 n, and then 4/6 is going to reduce to 2/3. Okay, so that's going to be your final answer for step 2. All right, and then for a sub 100, we are just going to plug that in. So we have 1/2 times the n value, which is 100, plus 2/3. Now you can decide how you want to do this. 100 times 1/2 is 50 plus 2/3, so it's just 50 and 2/3. You could just change it from the mixed number, 3 times 50, 150 plus 2. And you are going to want to leave these as improper fractions. All right. Any questions for me on that? Okay. For example 4, you need to find the 5th term, and you are given the 8th term and the 14th term. I wrote this out the way that your book does it, but there's more than one way to do this, and the way that the book does it is kind of long, to be honest. So the first thing I do is I organize my information. So they gave me that the 8th term, which is a sub 8, is 85, and the 14th term is 157. Okay, so in the book they have you find the common difference, and then you find a sub 1, and then you find a sub 5. I'm going to show you how to do that, and if you look it up in your book, it'll be the same. But I'm also going to show you some shortcuts to this as well, and then you can decide what you need to do. So this way is helpful if you have to find a sub 1. But please know there's more than one way to get here, okay? So when you're finding the common difference, you can use this equation, a sub n equals a sub 1 plus n minus 1 times e. And what's great about this is a sub 1 is replaceable with any term number. Okay, so if you have a sub 14 and a sub 8, what you can do is you can rewrite this so that you have a sub 14 is equal to, and instead of a sub 1, you can write a sub 8. But because this is a sub 1, this is n minus 1. So in this case, if it's 8, instead of minus 1, you're going to have minus 8. The n in this case is 14. So you're going to have 14 minus 8 times okay, so if this is an 8, this is an 8. This is 14, so this is 14. Okay, those correlate. Now we're just going to do some substitution. Okay, so a sub 14 is 157. A sub 8 is 85. And now we can just solve that. Okay, so 157 minus 85 is going to be 72. 72 divided by 6 is what? What multiplication is that? 12. Okay, were any of you thinking of another way to solve that? Yeah, let's think about why that works. So if you find the difference of the outputs over the difference of the inputs, that's the same thing as finding the what? The slope, exactly. And what type of function is this? It's linear, okay? So you can set up, you can find like the slope. Think of it as this is your input, this is your output, this is your input, this is your output. So your y2 minus your y1 over the x2 minus the x1. Okay, it's the distance between the outputs and the distance between the inputs. And you will still get 72 over 6, which is still going to give you 12. Okay, so that is your value for D. So you can use that slope equation. Okay, so whichever one you want to use is fine. I don't care which one you use as long as you show me what you're doing. Okay? Alright, and then you can skip step 2 and go to step 3. That's what I recommend, but like I said, your book does have you find a sub 1, and you might have a question that says also find the first term, and that's what this is good for. You can also just, you know the difference is 12, and this is a sub 8, how could you find a sub 5? Yeah, you could do, well, 12 times, how many times did you have to subtract 12? If this is 8, you want to get to 5. Yeah, what is it, Lucas? Yeah, 3 times, right? Because if you do it once, you get a sub 7. Do it twice, a sub 6. Do it 3 times, a sub 5. Okay? You can absolutely do that. Again, just show me what you're doing, and that is fine. So I'm giving you lots of strategies for this one. So one way you can find a sub 1 is you can use an equation. If you use an equation, you do have to plug in a sub 8 or a sub 14. I always like to use the lower one because it generally means I'm working with smaller values. So if I plug in a sub 8 for a sub n, this becomes a sub 1 plus 8 minus 1 times 12. Okay, my a sub 8 is equal to 85. Okay, and then 7 times 12 is going to give me 84. And then what's my a sub 1 going to be? A sub 1 is just what? 1. Okay, so if they ask you to find a sub 1, you can use this, or you could just subtract 12 7 times. Alright, and then I'm just going to put a little note here, just only use this step. If you need to find a sub 1. Otherwise, it's just extra and you don't need to do it. Okay, because there are ways that we can work around it. If you do step 2, then when you go to step 3, if you use this, then when you're finding a sub 5, you can use the a And that's because you already found a sub 1. So it's just 1 plus 48 to get 49. Okay, or what I'm recommending you do is you don't need to find a sub 1. As long as you have the common difference, you can use a different equation. Or skip step 2 and just use a sub 5 is equal to, and remember, a sub 1 is replaceable. So we could replace it with a sub 8. That's fine. So what would I have in my parentheses? If this is a sub 5 and this is a sub 8, what would this be? 5 minus. So the first one correlates to the n value. This one correlates to 8. So you would have 85 plus negative 3 times 12. Remember what we said earlier? You had to subtract 12 3 times. This is the same thing. So 85 minus 36 is going to be 49. Okay, so I'll give you some time today to practice so that you can figure out what method you want to use here. Okay? What I recommend is that you find D one of these 2 ways and then jump to this step. Alright, and then for the last one, it says which term of the sequence is 8.5. So if you're trying to find the term, you are trying to find n. Finding the value of n. Okay, and then they give you this sequence. So what I want you to do is find the common difference. If you can plug it in here and solve for n, that would be great. If you need some help with that, I'll show you what to do. Okay, but I definitely want you to find the common difference, and I want you to plug that into the equation. G and G, what'd you get for your common difference?
1.5.
Yep, and it will make sure that you guys put your negative on there, okay? So 22 minus 23.5 is and then once you have that, you can substitute that into your formula. Now, keep in mind, you know what a sub 1 is. Your a sub 1 is 23.5. Okay, now we have the difference, negative 1.5. What we also need, because we're going to solve for n, we need a sub n. Your a sub n, the nth term is 8.5. Okay, so a sub n is 8.5. So we're going to substitute 8.5 equals 23.5 plus n minus 1 times negative 1.5. And this one you can use your calculator for. Okay, so 23.5 and 1.5 is going to give you 25. And then this is just a linear equation that we're going to solve. Okay, so we're going to subtract 25 from both sides. Okay, and the difference between 25 and 8.5 is 16.5, so this will be negative. And then we divide. Alright, and then Cedric, what'd you get for your final value for n?
Sorry for the interruption. At this time, please release the boys golf team. At this time, please release the boys golf team. Thank you.
Okay, so this is going to be the 11th term of the sequence. Okay, so whatever your value is for n, that's going to be the term in the sequence.